Well, greetings everyone. Today's notes are on solving systems of equations, something that we've learned how to do in the past. We just need a little review on some of this. There are three main methods to solve a system of equations. One is graphing, one is substitution, and one is addition or elimination. Now, graphing works really well if all of your equations are in this format, y equals mx plus b. So if we have a couple equations that look something like this, graphing is probably the easiest way to go, especially if we have a graphing calculator. Substitution works really well if we have something that looks like this. If we have a system of equations where one of the variables is already by itself, one of the variables is already solved for. So if our system looks like this, we could plug all of this information, whoops, it should be a y, all of this information in place of x up here. Addition or elimination works really well if you have a system of equations that has everything lined up, like your x's on the, you start the equations, then your y's, and then equals your solution. If everything's lined up, x's, y's, equal sign, answer, addition or elimination works out really well. So let's take a look at a couple different systems of equations. Oh, before we do that, for each of these we could have no solution. Now, no solution occurs if you graph and if you run into parallel lines. Or it doesn't even have to be lines. If you graph two equations and those graphs do not intersect, that means you have no solution. And if you're solving using elimination or one of the other methods, if you end up with something that like this, 2 equals 5, something that just makes no sense, then there's no solution. Now, infinite solutions occur if you graph the same exact equation twice. Like if you have the same line graphed twice right on top of each other. And if you use elimination and you end up with like 5 equals 5, that means your system of equations has infinite solutions. Okay, so let's jump in. First example, we need to solve this system of equations. Now, you'll usually see problems like this where you're not being told the method to use. So we could use elimination, we could use substitution, we could use graphing. It's up to us. So the more we know and the more competent we are at solving systems of equations, the more likely we are to pick the most efficient method. And if you look at this system, both equations are set up y equals mx plus b, so we're graphing two lines. And if we can see where those lines intersect, then we'll be good to go. So I'm going to get my graphing calculator out. Let me pull it over here. Here it is. And I want to graph these two equations. So I'm going to press my y equals key. We'll type those both in there. I've already got them in. Y equals 2/3 x plus 5. And y equals negative 2x minus 11. If I take a look at that graph, let me pull that out here. We've got two lines that intersect at a point over here. Now we can just count on our screen, but that might not be the most accurate way to do this. So another thing we can do on our calculator is if we press our second key and then the trace key, we get into this calculate menu. And we can calculate the intersection of these two lines. So we're asked first curve, let's just hit enter for that. Second curve, hit enter again. And then guess, we can just hit enter once again. There we go. And it tells us that that intersection, and I'll bring this on my screen, is at negative 6, comma 1. Okay, so what does that mean? So our answer here, let me write it as a point, negative 6, comma 1, meaning this is the value for x and y that we can plug into both of these equations and make them both true. Okay, so let's take a look at another example. Second example here, we've got the system of equations. Now, I would not try to graph these two lines. Here's why, because notice the format, they're in standard form, they're not in slope-intercept form, so although we could solve these both for y and graph, that's more work than I want to do here. So since everything is lined up, all the x's, the y's, the equal sign, the answer, everything is lined up, I'm going to solve this using addition or elimination. Now, as it's currently written, none of those variables will cancel out or be eliminated if I add these together. But if we multiply the first equation by 5 and the second equation by 3, what that will do for us is make it so we have 15y on top and negative 15y on bottom. When I add these together, those y's will be eliminated. Now, I could have chosen to eliminate the x's as well. Basically, we have to pick one of those variables, multiply by something that's going to eliminate that variable. Okay, so if I multiply everything on top by 5, including the answer, I get 20x plus 15y equals 55. If I multiply everything on the second equation by 3, including the answer, I get 9x minus 15y equals 90. And if we add these two together now, notice 15y and negative 15y, those are gone. So adding these together, I get 29x plus 0y equals 145. If we divide both sides by 29, we get x equals 5. All right, good deal. So we've got half of our answer already. We've got x equals 5. Now we need to find what y is equal to. So we need to take that 5 and plug it into one of these equations. Doesn't matter which one. I'm just going to plug it into the top one. 4 times 5 is, I'll write it out here, 4 times 5 plus 3y equals 11. So I've got 20 plus 3y equals 11. If I subtract 20 from both sides, I've got 3y equals negative 9, which leads me to y equals negative 3. So now I'm going to write this as a point, 5 and negative 3. And again, we could have graphed both of these. So we'd have two lines that intersect at this point, 5, negative 3. But simply because of the way the original problem was formatted, it's probably easiest to solve this using addition or elimination. Okay, let's look at one final example. We've got y equals x squared minus 4 and y equals x plus 2. Now we could graph both of these. We'd have a parabola on top because of that x squared. We'd have a line on bottom. Now, if we graph a parabola and a line, it's possible that it'll look something like this and we'll have no solutions. It's also possible that it will look something like this and you'll have one solution. So it might just touch that at this point right here. You have one solution. It's possible that we'll have a graph that looks like this and we have two solutions. So we've got a lot of different possibilities here for that graph. Now, instead of graphing though, I'm going to use a different method. I'm going to use substitution because we know y is the same as x plus 2. So I'm going to take that x plus 2 and plug it in place of this y on the top equation. Here's what that gives me. X plus 2 is equal to x squared minus 4. So now let's just move everything onto the right-hand side of the equation. So I'm going to subtract x from both sides, subtract 2 from both sides, which gives me 0 equals x squared minus x minus 6. All right, we've seen these kind of problems in the past. We need to factor what we have. I know x times x equals x squared. And I know, let's see here, I need two numbers that multiply to negative 6, add to negative 1. If I break this down as minus 3 and plus 2, that should work for me. So now we've got really two situations. X minus 3 might equal 0, and x plus 2 might equal 0. Which leads me to x could equal 3, or x could equal negative 2. So now we've got two solutions here, two different values of x that work. That means we're going to have two different points. If we were to graph these, they'd intersect at two different points. 3 comma something and negative 2 comma something. So to find the y values, we have to plug those into either equation. I'm going to use that second one. It just looks a little simpler. If I plug 3 in there, 3 plus 2 is 5. So if x equals 3, y equals 5. If we plug negative 2 in there, negative 2 plus 2 is 0. So if x equals negative 2, y equals 0. Okay, so that's an overview of how to solve systems of equations using three different methods. So your best bet know all three very well, and use the appropriate method that will lead to the least amount of work for you. You want to try to use the most efficient method.